Hi class, welcome back. So we are going to do the K nearest neighbor part of the lecture with Python. So when you go to the prep, you're going to be able to see the second option link to download the lecture Python that you can upload to your Colab. So click on the link, you're going to download it, and then once you go to your Colab, you can click Open Lab, and then you're gonna be able to choose which file do you want to open. So you can go upload and stuff like that. And so, or you can just go upload notebook, and then choose the upload the file that you just downloaded. Okay. Now, another thing that you're gonna need here is you're gonna need this classified data, which is a CSV file. So please click download, and then you're gonna open it up in here. So you're gonna go, so you're probably not gonna see this part right here. So you just need to click the folder on the left side. And then you're gonna be able to see this upload button where you can actually upload your file. Okay. And so I already uploaded there, so I don't need to do that again. All right, so we're gonna start by reading the instructions. So here, this is a K nearest neighbor with Python. You have been given the classified data set from the company. So we have the classified data on the left side. It's a CSV file. They have hidden the feature. They have hidden the feature column names, but have given you the data in the target classes. We're gonna try to use KNN to create a model that directly predicts a class for a new data point based on the features. Let's grab it and use it. So we're gonna have it there. Let's now what we're gonna do is we're gonna import some libraries. So we're gonna start by importing. We're gonna import pandas as PD. Let me see. Maybe I can make this a little bit bigger and just remove this part. That way you can see it a little bit better. Usually, if you have I know that some of you might be working on a computer, but I recommend that you buy or have a um, to have a monitor. I recommend that if you're gonna be a computer scientist, have multiple monitors, or at least if you're gonna have a laptop, have an extra monitor so that way you have two screens. That is gonna make you a much more efficient programmer. So I always recommend. Please have multiple monitors. We're gonna also import matplotlib, and we're gonna do and then it's gonna be matplotlib.pyplot as PLT. So we're gonna name it PLT. That's the nickname that we're gonna give it to, instead of calling it the matplotlib.pyplot. And then we're also gonna do numpy. So remember, numpy is an array. It's just for the arrays, and it has a lot of other important features. Remember that the advantage of having information stored as a numpy is that it puts everything in an array. It makes it a little more efficient to process. And then we have pandas, which makes it into a series, and multiple series makes it into a data frame. Matplot is to be able to data visualize our data. So now that we have imported these libraries that we're gonna use, we're gonna create our data frame. And here we're saying we're giving instruction to set the index column to 0, so to use the first column as an index. So what we're gonna do here is we're emphasizing that from our data frame, we want the data in the first in the first column to be represent our index. So that would be like 0, 1, 2, 3, 4. So we're gonna extract the information using pandas read underscore CSV file. So we're gonna use the CSV file. It is a constructor that is going to take a classify. We're gonna take this classify folder. So the best thing to do is to go here and choose the copy the path, because that just so that you know where is that located in your folder. So that's the best thing you can do. That way you don't make a mistake on writing where the location of your file is located. And then, like we said before, we wanted to we want to make sure that our first column is our index. So we're going to say that it's going to be our column 0. Then we're going to click this to make sure that they're both running. There's no mistakes. And then now what we're going to do is we're going to see the first 5 rows of our data frame. Remember, if we just do the data frame dot head, is going to give us the top 5 rows of our data frame. If we want to have 10, then we need to specify 10. If we want to have 1, we can just do 1. But if we don't put any number, it's going to give us the 5 of them. If we want to do the last one, we can do tail. Right? So we can see here that in the first column, we have index 0, 1, 2, 3, 4, which is going to represent our index. Then we have a bunch of features here. Each column, WTT, PTI, EQW, SBI, LQE, QWG, FDG, PGF, HQE, NXJ are all your features. Those are going to, your columns, they are going to be your features. Those is the information that we're going to use to be able to classify our label, our target class. Right? So our target class is in the end right here. So we either have 1 or 0. So this is a binary classification. So we're going to use this information to be able to classify our row or data as either 1 or 0. So this is your features and this is your target label. Okay, so we know that this is a classification because remember the target class, right? Here we already gave you the name target class, right? Sometimes we don't, but in this case we did. We already telling you by looking at the data, right, that the values that we have here is either one or the other one. So this is not a continuous value. So it's a classification, it's a class. So we call it discrete, right? So it's either 1 or 0. So whenever you have that, then we know our spidey senses should be saying, hey, you should be thinking of using a classification model. In this case, a KNN, a K nearest neighbor, will give you a classification, will allow you to classify your data. So that's why we're using it in this case. Now, sometimes it's very useful to be able to standardize the variables. So because the KN classifier predicts the class of a given test observation by identifying the observation that are nearest to it, the scale of the variable matters. Any variables that are on a large scale will have much larger effect on the distance between the observations and hence on the KN classifier. The variables that are on the small scale. So what we want to do here is we want to make sure that all the values are within the same range. So that way no feature will have more power over the other ones when we classify them. So that's the purpose of doing standardizing your variables. So what we're going to do here is we're going to extract from the sklearn dot pre-processing. So this is the part where we are cleaning our data before we can. This is the step number 1, step number 2, where we extracted the data and now we're preparing the data. We're making sure that it's in a useful way for us to be able to train it into our model. So what we're gonna do is we're gonna standardize our data by using the standard scalar. So we're gonna call it scalar equal standard. So we're gonna create this object standard scalar, and sorry. I don't know what happened. I think I misspelled it. So if you can see here, I'm sorry. So I misspelled it. So it is sklearn.preprocessing import standard scale. And now we can run this. Sorry, I think one more. Yes, I misspelled it right here. Standard with a D there. Let's see. Standard scalar with an extra R there. All right. Okay, so just careful with your spelling. Scalar. So let me make sure that I copy this and put it right here. That way I make sure that I'm writing it correctly. So now I created this object scalar that's going to scale my data. So I'm going to use scalar, my object to fit my data. Now what I'm going to do is I'm going to use a drop because I don't want to include my target class. I just want to have my features, all my columns except the target class. I don't need to scale the last one, and I'm actually creating my data frame that only contains my features because I want to fit that one when I train my model. So I don't need the last one, and we want to exclude it. So the best way to do it is just drop it because we're gonna have instead of just adding one by one, we can just drop it uh, instead of just adding one at a time. So we can just drop the one that we don't want, that we don't need, and it's going to be on the columns. So this is going to be based on the columns. Remember, axis equals to 1 is talking about referring to the columns. If we want to drop a row, we need to do a axis 0. So we run this. Now we're actually scaling our data on this scalar object that contains all the features except the target class. So now what we're gonna do is we're going to use our scalar to transform our data. So we're gonna scale our data, scale features. So right now we're just doing a fit, and now what we're gonna do is we're gonna scalar our data to transform it, and so we're gonna do the same thing that we have here. We're gonna grab this data frame, and so we're gonna transform our data from our features except the target class. And let's run this again. And now let's see what we get. So now what we're gonna do is we're gonna create this data frame with just the features. Features. Let's call it just feet. We're gonna create this data frame, scale, features, columns equal df dot columns, and we're gonna select everything except the last one, the last column. So again, we're creating this data frame that is going to contain this data as our data frame. So we're gonna grab everything except the last one. So and let's see what we have here. So you can see here, sorry, underscore feet dot head. We want to see. So you can see here that we have scale our data. You can see that this is now different, right? We had before 0.913917, and now it's negative 0.12352. So we have scale our data so that it can be within the range of -1 and 1. So now represented by each column. So they're all going to be weighted about the same. And so now what we're going to do is, now that we have prepped our data, now we're ready to part 3 and 4, which is split our data and test and train our data. So we're going to go from sklearn.model selection import train test split, and then we're going to do x train x test y train. Remember, we have the x capitalized and the y lowercase because the x contains multiple features, multiple columns, and the y only contains one. Y underscore test equals train test split scale. We're going to do scale features as our values for our x, and then we're going to do df target class for our y value. Okay, so this is going to split up our scale features between our x train and our x test, and then it's going to separate our y train and y test with our target from our data frame, from the column from our target class from our data frame. So we'll run this too. Actually, let's add actually here another. We need to. Sorry, I forgot to set the test size, right? Thank you for reminding me. It's gonna be 0. Let's make it 0.30. Even though most of the time we have 20% for the test size, let's make it in this case 30%. Just to change it a little bit. And let's now that we have this, remember that we're trying to come up with a model to predict whether someone will target the class or not. So we'll start with the k equals 1. So we're gonna import our k neighbor model, right? So that we can train it. So it's gonna be from sklearn.neighbors. If I know how to spell neighbors, import k neighbors classifier, and let's make sure that this is running. It's taking a while. Sorry about that. But I guess I can start writing over here. So we're gonna import our k neighbor classifier, which is going to be our KNN. I don't know why. Oh, there you go. So it worked. So now what we're gonna do is we're gonna create our model, which is going to be an object of the k neighbor classifier. And remember that we need to specify what our hyperparameter will be. In this case, we just said we want to do 1, right? So we're just going to do 1. So our size of our k will be 1. So we're going to be looking at neighbors of size 1. And then we're going to fit our, we're going to train our model by doing kn.fit. Remember, this is the same thing as the other ones. We're going to use our x train and our y train to train our model. And then what we're gonna do here is we're gonna make a prediction now. We're gonna come up with a prediction if we use our kn.predict. We're gonna use what is it going to be when we put the test. And I made a mistake here. Object has no attribute predict. It is predict with a C, sorry. And so we have our predictions. And now what we want to do here is we want to evaluate our predictions. So the way we're going to evaluate our predictions would be from sklearn metrics. We're going to use the matrix. I believe it's a function, matrix import, and we're going to import the classification report, and we're going to do the confusion matrix. So we're going to we're going to import those to our file, and now what we're going to do is we're going to print what is our confusion matrix. It's not confusion matrix. There you go. And we're gonna put we're gonna compare our y test and our predict to see how well they did. And we have 129 that was correct, and that was true positive, and then 144 that was true negative. And then we have 10 and 17. That's actually pretty good. It's not bad, right? So this is to be able to visually see what our confusion matrix would be. So now let's see what we have here when we do the classification report. So now let's measure the prediction recall, F1 score, and support. So the way we can do that is by using the classification report. I think it's that one. And we're gonna just plug in our y test. So this is very simple. We don't have to do any of the math part. We just have to use our tools, right? As long as we know what we want to do, we can just use our tools to be able to execute and calculate these numbers. So this is saying that our predictions, our precision for 0 is 93%, and the precision for 1 is 89%. It's not bad. Right? There's other scores here that let us know about what is the accuracy here. So we have a recall of 88% and for 0 and 94% for a 1, and an F1 score for 0 and 91 for 1. So what this is doing is practically calculating a different measurement of precision. And so this is a way to be able to check how well we did. Now, so far we only have tried only one k value, right? We tried k value equals to 1. But what about if we want to check, if we want to be able to see which k will be the best one? I mean, we can do try and error, like try 1, try 3, k equals 3, and then we can try k equals 5, k equals 7. Why do we want to not use k equals 2? Do you guys remember that? So remember that we want to make sure that our k values is always odd. The reason is because, remember, we're looking at our neighbors to be able to vote to determine where you're going to fall in. So if you have an even number of neighbors, then you could have a tie. And we don't want to have a tie. So we want to make sure that we have odd numbers so that way we don't have a tie. All right, so let's go ahead and see what we can do to be able to find a better k value. So what we're gonna do is we're gonna create this array, this list called error rate, and we're gonna go through a for loop. So we're gonna do a for iteration of our I in range. So we're gonna try our k values to go from 1 to 41. So this is what we're gonna be trying right now. We're gonna try to see, we're gonna try our k to be between 1 all the way to 41. And so practically what we need to do is just do the same thing that we did before, right? We're just gonna copy this. So we're gonna use a different k, right? So we're gonna do exactly the same thing, but instead of being an 1, it's going to be an I. We're going to train our model, so that's fit. So we're just gonna do the same thing here. And then we're going to predict. So we're gonna use the prediction part. So it's just everything the same. So it's nothing that we didn't do. Let's call it the prediction I. Just because it's a little bit different from the other prediction. And then our error rate. So we're gonna save this error rate dot append. So we're gonna add this errors in our array in our list. So we're gonna calculate the mean, the average prediction I that does not equal to my y test. So we're trying to calculate, we're trying to measure how what's the error in our k values, right? So we want to do the least one. So we created this. So now we created this. We're adding it to our error rate, and now what we're gonna do is we're gonna graph it. Let me make sure that this is working well, so it doesn't have any mistakes. Okay, good. So now what we're gonna do here is we're gonna plot our graph. So we're gonna use a figure to graph. The fixed size will be equal to the 10, comma 6, and so that's gonna be the dimensions 10 by 6. Our graph is gonna be, we're gonna plot our graph using a point plot, and it's going to range our numbers from 1 to 41. So we want to have our range of numbers from 1 to 41 for our points. And then this is for our x values, and for our y values will be the error rate. The color for our will be blue, and the line would be line style would be dash, and then our marker will be a O, and then our marker base color would be red, and then our marker size would be 10. So this is a good review for our plotting parameters. Let me put this in quotations. There you go. So so that would be for our graph. Now we want to put some titles there. So title would be error rate versus k value. And then our PLTX label will be our K. So that will be our X label, right? Remember, we're trying to figure out which one is our best K. And then our Y label is going to be an error rate. All right, so let's see if this works. Marker size is not spelled correctly. Marker, I'm missing, that's a maker, not a marker. There you go. And there you go. So now we can visually see our K values. So it seems like our K values are better, are smaller once we get to 23, something around there, then it's just oscillating between 0.075 and 0.65. So it seems like after k equals 23, or even k equals, maybe even k equals 17 will be probably better, right? I mean, we did reach a pretty low point on k equals 6, so that's pretty good. But let's see if we try this again. Let's see if that would give us the same number. So let's do this again. And we're going to train our data and draw our data again, our k value. And you can see it kind of gives us the same values, right? So that's good. Probably because we actually have our fixed number here. We choose a, did we choose a value? No, I don't know. We didn't. Oh, good. It's nice. All right, so it seems like we could have a 6 or a 7, right, as probably the best K that we can get. Nice. And so we can see here that that our KN, when it is our K neighbor class Sapphire with K equal to 1, let's see, let's go back here. So here we can choose, we can see the K23, right? K23 is when we start oscillating between those two. That stops going up and down, right? So we do see that 7, but then it goes up all the way up to 0.085 when it is 13. So, but after 23, kind of just oscillates between the values of 0.77 and 0.65. And so we then have, we're just going back to our k, when a k equals 1. So we're going to fit this again, just to go back to that. And we're going to have our x train and our y train. And then we have our prediction equal to KNN dot predict x test, and we're gonna print with k equals 1, and then we're gonna print a \n. And then we're gonna print our confusion matrix with our y test compare with our pred. And then, oh, sorry, not yet. We're gonna print also our classification. Wait. Our classification also. So let's do print classification report with our y test and predictions. So there you go. So we can see our data here. And let's do the same thing that we did, but now with the K23. So we're gonna copy this and we're gonna do it with the 23. So all we have to do is change this to 23, and everything else will be the same. And we can see here that we can compare the two K values, right? It seems like we only had an improvement of 1% for our prediction for 0, but we had a 2% improvement on our prediction for 1. It's not bad, right? In the recall, it improved to 90% versus 88%, and a 95% from 94%. So there is an improvement there, not much. So is it worth it? Probably, I mean, depends, right? But I mean, because remember, we're now counting. Well, we still it wouldn't do extra work if we actually have k versus one. It wouldn't make that much a big deal. So we can actually keep the k equals 23, and that will be a better performance. Some more performance out of the model by tuning the k value. So here what we did is we actually, this process of figuring out which one is your k value is what we call the hyper